Hi, this is Roberto, and I'm going to teach you physics. Um, Yesterday we talked about Newton's law for viscosity. Remember, we are talking about rheology. This is not an introductory class. This is like intermediate or even advanced rheology because we are studying the movement of fluids and the behavior of several properties of fluids. The more relevant is viscosity, okay? Viscosity. And we saw viscosity, and we're going to study different liquids. In this case, we're going to study different liquids according to its behavior with viscosity. Why? Why? I tell you a small story so you understand. I don't know where I read it, but I read a case of the blue helmets, I think they're called, of United Nations, okay? I think they are called blue helmets, but I'm not sure. Yeah, so blue helmets is the United Nations. Well, some countries contribute to United Nations, and when there's like a peacemakers, I think they're called. So they send troops, regular troops, but with a blue helmet in the United Nations. So they arrived in Africa, and there was some kind of civil war or something like that. I don't remember the details. But the soldiers found starving children. Apparently, the gums and the tongue were swollen, I think is the word, so they couldn't eat anymore. They were very weak, and they tried to make them eat, and without success. The soldiers were American, they were from the United States, and they tried to give them, they tried with all the foods they carried in the backpack. So they tried with peanut butter, okay? Peanut butter, and they come in the military rations of the United States, because it's very common food in the United States, not in Europe, but yeah. And they comes in small sachet. I don't know if you use small bags, like ketchup bags, these small ones. So they try them in and put it in the mouth of the children, the poor children there, and by sublingual, under the, that, I don't know if you, we can absorb nutrients under our tongue. It's called in sublingual, literally sublingual in Latin. Lingual means under the tongue, okay? And with that, at least they could eat something and be stronger. And then if you are malnourished, you can die. Of starving, or of the illnesses that accompany this. So when the soldiers came back, informed their superiors, and it was decided that they were going to prepare small bags with bags, yeah, with the same texture. That's the truth. The same texture, because the children could put them in their mouths. Same texture, but more nutritious. So the problem is that you change the food. Nutritious. You change the food, you change the texture. Imagine you want to add more protein, or I don't know, add vitamins, or even, I don't know, some medicines. So you change texture. So what they had to do, they had to first know the temperature of where this peanut butter was eaten by the children, and so they could reproduce the behavior of the fluid. And it was done in the lab. So the idea is that once you have more or less the idea of the force with which the children can chew, and you know the temperature and the texture you want to achieve, it's easier to copy this texture and these properties. For this, there are several instruments used to characterize rheologically. One of them is called rotatory viscosimeter or viscometer. The idea is that you have a fluid inside a container. Okay, this is the fluid in the container, and you put inside a cylinder, okay, that is connected to a machine, okay, something like that, and that can spin inside the fluid. So in an ideal fluid, the cylinder is called spindle, okay, spindle. If the fluid was ideal, or if I were ideal, I think if the fluid were ideal, there could be no resistance of of the movement of the spinning of this small cylinder. But since the fluid is real, it's like it reduces the velocity, and then it has a like a spring inside that is very well calibrated, and it compensates to achieve to keep the velocity, and then it's able to measure viscosity. So to give you a viscosity, to give you an idea, imagine of what happens. Imagine you're driving your car, okay, and then there is a slope. You're climbing a mountain. So imagine you want to go at 80 kilometers an hour, okay? The number is irrelevant, or miles per hour, doesn't matter. So with the same, you're driving at a constant speed, but when there is a slope, okay, velocity decreases to, I don't know, depending, it's kind of exaggerated, but suppose that speed lowers or goes down to 50 kilometers an hour, okay, because of the slope. So you have, if you want to go at 80 kilometers, you have to press the pedal, the accelerator. So that's the idea, same idea here. This slow with affects viscosity and slows down the spinning, so the instrument has to compensate to maintain the constant angular velocity, and with this the instrument is able to know viscosity. And to characterize the fluid, what we do in the lab is to measure viscosity versus the angular velocity, not angular, you call it shear velocity. Is related to agitation of the fluid, okay? Agitation velocity is there's a calibration between the angular velocity and the shear velocity. It comes from the manufacturer provides. So this is related to the agitation velocity. So depending on the behavior